All right, guys, obviously the key to this chapter is going to be being able to do lots of integrals, okay? So the first part of what I wanted to do for homework was on assignment 6.5 and number 9 through 22. Okay, this does not give me enough room. I'm going to go ahead and do it on another sheet of paper. Okay. Most of these, well, we're going to start by looking if it's just something that we can do just a straight integral on. That's going to be pretty straightforward, like number 9. So if I go, the 2 is a constant. That's allowed to just come out in front, right? And then we know that the integral of 1 over x is ln of x. And if you guys remember, the first fundamental theorem of calculus says that when we evaluate, we just go top minus bottom. Okay? You definitely want to know that the ln of e is 1, ln of 1 is 0, so this integral is 2. All right? I would recommend, as you are going through here, just so you get a better, practice with your calculator, since they're all, at least all the ones that are definite integrals, at the end, go ahead and just put it in your calculator, make sure you can type it in okay, plus it'll check your work as you go. All right? Okay, so remember, we just have to go out to the home screen. We're just going to hit Math 9, and like for this problem, it was 1, 2, e, and then 2 over x dx. All right, and you can just check and see that you got that right. Okay, not necessary, but good practice. All right. Now, you can do this one with u sub, but, sorry, I gotta move this over. I prefer doing this with reverse u sub, okay? So when I can tell that there's something like this on the bottom, I know that that's gonna be an ln problem, all right? The fact that the minus 1 is there doesn't really change anything. The fact that the 2 is there, well, all that changes is, okay, I'm gonna take the 4 outside. I know this is an ln problem. And remember, when we take the derivative with chain rule, we'd multiply by 2. Since we're doing the integral, we're dividing by 2. So it's gonna be 2 ln of 2t minus 1. And I'm going to be evaluating that from 3 to 1. I'll go ahead and leave the 2 outside. This is, when I plug that in, 2 times 3 is 6 minus 1 is 5. When I plug that in, 2 times 1 is 2 minus 1 is 1. And we know the ln of 1 is 0, so this is 2 ln 5. Okay? So again, if we wanted to check it, just come over here, we go. Math 9, 1 to 3 of, put this in a fraction, 4 over 2x minus 1 dx. Okay? And this, it shouldn't turn it into a fraction for me because it's not, but I can check it by saying, well, what is 2 ln of 5? And 2 ln of 5 is the same thing. So I am good. Okay. All right, so now we're getting into, this is definitely a u substitution. So what we're going to do is identify what u is. If you have e to a power or a number to a power, typically the power is what u is going to be. Derivative of that is 2x dx. Well, I have an x dx, I just don't have a 2. So I put that in, and I do a 1/2. Now this turns into e to the u du, and I know the integral of e to the u is e to the u. Okay, so my final answer is 1/2 e to the u, which is x squared minus 1 plus c. Remember, whenever we're not evaluating, guys, we're going to go ahead and put a plus c on the end. Those are our indefinite integrals, okay? All right. These are both like very similar questions, but different, obviously. One of them has x over x squared minus 1. The other one has x squared minus 1 over x. So I need you guys to recognize what you do on each one. On number 12, we are going to go ahead and do u sub. And we're going to let u equal the bottom. On number 13, because there's a single term on the bottom, we're actually not going to do that. We're going to split up the fraction. That's what you do when there's a single term on the bottom, okay? All right, so let's look at the u sub first. If u is x squared minus 1, du is 2x dx, I need a 2 and a 1/2. And so this turns into 1 over u squared du. Nope, 1 over u du, sorry. The x squared was part of the problem. So 1 over u du, which is an ln problem. So I can put that back in, and it's 1/2 ln x squared minus 1 plus c. Okay, now here, I'm going to do this differently. I'm actually going to split up the fraction. So it's x squared over x minus 1 over x. And we know that x squared over x can simplify and just be x. Okay? When I integrate this, the integral of x is x squared over 2. The integral of 1 over x is ln of x. Okay? And then I just put a plus c on there, and I'm good to go. All right. When you start seeing things like fractions and you're like really not sure, I mean, most of the time it's going to be a u sub. I would say more than half, so at least try it. Now, a lot of times it'll take what's on the bottom, and if u is y squared minus 3y plus 2, du is 2y minus 3 dy. And then I look, do I have a 2y minus 3? No, I have a 4y minus 6. But I can turn that into a 2y minus 3 by multiplying by a half. A half of 4y minus 6 is 2y minus 3. If I put a half in there, I need to put a 2 out there. I'm good to go. Okay, so this turns into 1 over u du with a 2 out front, ln u. So my final answer is y squared. So 2 ln y squared minus 3y plus 2 plus c. Okay, you can do this as a u sub. Since u is 1 and du is just dx, you don't really have to. What you can do, you can kind of do it as like a reverse chain rule, I guess. Bring that up. And so it's actually negative x plus 1 to the negative 3. And the fact that it says x plus 1, it's not really going to change anything because, the derivative of x is 1. So it's like with chain rule when we had to multiply by 1. It's the same idea. Okay, so I get, if I add 1 to the negative 2 over negative 2, which is those two negatives will make a positive. And so it's positive. There's an x plus 1 squared on the bottom plus c. All right, let's check out 16. This is a u substitution. Really annoying because it's using the letter u, so that's dumb. So I guess we could turn these into x's and do a u sub. Or if that gets confusing, we can just use another letter over here. We could do a w substitution, which is strange, but anyway, change the letters around if you want, but just make sure to notate it in your work. Okay, that's 2u du. So I have a 3, and it's like, how do I change a 3 to a 2? I do 2/3, 3/2. All right, so this turns into 3/2, and then it's the cube root of w dw. All right. Now the cube root on the bottom is w to the 1/3 power. If I add 1 to that, negative 1/3 plus 1 is w to the 2/3.
For the interruption, and thank you for helping us celebrate Honor Roll Kids. We missed a few kids yesterday and today. Is there
Okay, so I go w to the 2/3 times 3/2, which gives me 9/4 w to the 2/3 plus c, and I'll put back in there the u squared plus 1. Okay. Okay, here's another u sub question. In this one, u is what's underneath the square root. So u is ln of x, which means du is 1 over x dx, which is exactly what this is. So this entire thing just turns into square root u du. Well, the integral of a square root, if that's u to the 1/2, so it's u to the 3/2 times 2/3. So this will be 2/3 ln to the 3/2. And I'm not evaluating, so I'm just going to put plus c. Okay, this is another u sub. This time u is going to be what's in the parentheses to the 5th, not the x. You'll see what happens to that in a minute. So if u is 1 plus ln of x, derivative of 1 goes away. The derivative of ln of x is 1 over x dx, okay, which is here. I did not need this 2, so I can just take it out. And then this becomes 1 over u to the 5th du. That and that is all du, okay? All right, continuing on. The integral of u to the negative 5 is u to the negative 4 over negative 4. And we know that that reduces to negative 1/2. So it's negative 1/2 u to the 4th on the bottom plus c, and I'm just going to plug back in my u. Okay, 19. Again, a lot of times when you have a fraction, the u is what's on the bottom of the fraction. All right, so for example, if u is sine y minus 2, derivative of that is cosine y dy, which is exactly there. So this turns into 1 over u du, which is the ln of u. So we would write this as ln sine y minus 2 plus c. Number 20 is very, very similar. E to the 2y over e to the 2y minus 2. Again, if I let the bottom part equal u, the derivative of that, okay, derivative e to the 2y is e to the 2y times 2, and the derivative of that goes to 0. And I have an e to the 2y dy, I just don't have a times 2, so I'll do 2 1/2. And then it just becomes 1 over u du. So again, that's an ln problem. So it's 1/2 ln e to the 2y minus 2. Okay, last two questions real quick. Just a note, if you're ever trying to integrate a tan problem or a cotan problem, I want you to turn it into sine and cosine, and then do a u sub, okay? So 21 says cotangent of 5x. All right, so I'm actually going to turn that into, cotangent is cosine over sine. And then I do u substitution, and you guys, the thing I pick for u is what's on the bottom, okay? So I get this. U is sine 5x, du is cosine 5x times 5 dx, all right, because of the chain rule, which means I have to do a 5 and a 1/5, and then this becomes 1 over u du, which is ln u, so it's 1/5 ln sine of 5x plus c. All right. And the last question on this part right, let's look at this last problem. Speed mode. I've been doing these all in speed mode. You might need to slow it down a little. Okay, u is y squared, du is 2y dy. I need a 2 1/2. And then I'm going to get 1/2 tangent u du. Oh, but what is the thing I just told you? We don't have an integral tangent. I have a derivative, not an integral. To integrate this, I have to split this up to sine over cosine and do like another u sub. Okay, now if I had thought about it ahead of time, I probably would have taken that into account with the previous part, but whatever. I'll do a w sub here, and I'll go, okay, w is cosine u, so dw is negative sine u du, okay? And then this turns into negative 1/2, 1 over u du, 1 over w dw, actually. So it's negative 1/2 ln w, which converts to negative 1/2 ln cosine u, which converts to negative 1/2 ln cosine y squared. So it is plus c, possible to do, u sub twice, but if I'd seen it from the beginning, I should have changed the tangent to sine and cosine and gone from there. All right, we'll do another video in a minute of the other part that I wanted to go over with you guys.